Yeah, see, eighth sum, y equal to, you can take it as y equal to cos. If it is in a root, I will write it as x to the power 1 by 2. X to the power 1 by 2. Cos of x to the power 1 by 2. It is not in a power. This is x to the power 1 by 2. See here, don't get confused. Cos of x. That x value, it is in a power. That's all. How many terms are there? 2 terms. Good. How many terms are there? 2 terms. Because cos of x, 1 term. Then x to the power 1 by 2, 1 term. If it is in a power, that is a 3 term. Okay. See here. Differentiate with respect to x. Differentiate with respect to x. dy by dx equal to cos of x. Cos of x equal to minus sin of x to the power 1 by 2. Cos of x equal to minus sin of, because cos x formula is minus sin x. Minus sin of x to the power 1 by 2. So this part is over. Cos over. You concentrate on x to the power 1 by 2. So what is the formula? N into x power n minus 1. N into x power n minus 1. So it gives minus sin of x to the power 1 by 2 into 1 by 2 into x to the power minus 1 by 2. You take the LCM. Previous sum I have done it. Okay, see here, x to the power minus 1 by 2. So what is the value you are getting? Minus sin of x to the power 1 by 2 by 2. It is, the power is in negative, so I can bring it down to x power 1 by 2. 2x power 1 by 2. You can replace that x power 1 by 2 into root. So minus sin of root x by 2 root x to root x. See, exercise 5.2, ninth sum. Prove that the function f is given by f of x equal to modulus of x minus 1, where x belongs to R, is not differentiable at x equal to 1. When the function is differentiable. First one is the limit exists and it is continuous. The limit exists and it is continuous. Then it is a differentiable function. Or otherwise it is not a differentiable function. I think you have learned in the 11th standard itself. See here. See modulus of x minus 1. When I am substituting f of x, see here. F of x equal to y. That is y equal to modulus of x minus 1. When I am substituting x equal to 0, what is the value of y? What is the value of y? Y equal to modulus of minus 1 is nothing but 1, because what is the property for modulus? If it is minus also, then you are getting the value positive. I am substituting x equal to 1, x equal to 1, y equal to 0. See the diagram. See the diagram here. See 1 comma 0 comma 1. The point is 0 comma 1. Here the point is 1 comma 0. So it will reflect like this. Because modulus takes the positive value, it lies in the first quadrant. So 1 comma 0 and 0 comma 1. See, when I am taking out the modulus, what we are going to write? We are going to write plus or minus. See here, what is f of x equal to modulus of x minus 1. I want to remove this modulus symbol. I will write f of x equal to positive x minus 1, negative x minus 1. That is, the modulus meaning is nothing but what? Plus or minus. Whatever term, it is positive or negative, you are getting the value positive. So I have removed that modulus. What I am going to write? X minus 1. This is positive. So I will write x greater than or equal to 1. Because differentiable at x equal to 1. So x greater than or equal to 1. If it is negative, x value is less than 1. So now we are going to see left hand derivative and right hand derivative, whether it is equal or unequal. Okay, see here. Yeah, now we are going to see about the left hand derivative. See about left hand derivative. What is the formula for that? Limit x tends to 1 minus. What is the meaning for that? It is left hand derivative. Left hand derivative f of x minus f of a. What is the value of a here? 1. F of a by x minus a. That is x minus 1. Limit x tends to 1 minus is left hand value. F of x minus f of 1 by x minus 1. To change it into h tends to 0. Limit h tends to h tends to 0. If it is left hand, what is the value we are going to write here? F of 1 minus h. If it is right hand, we have to write f of 1 plus h minus f of 1 by x minus a. H value is 1 minus h minus 1. See, I will repeat here. It is left hand derivative. We are going to see the left hand derivative. Limit x tends to left hand derivative 1. F of x minus f of 1 by x minus 1. What is the formula? F of x minus f of a by x minus a. We change it into h tends to 0. Limit h tends to 0. F of, if it is left hand limit means f of 1 minus h. If it is right hand limit means f of 1 plus h. So f of 1 minus h minus f of 1 by 1 minus h minus 1. See here, plus 1 minus 1 get cancelled. See, limit h tends to 0. Limit h tends to 0. F of 1 minus h minus f of 1 by minus h. Here I am discussing the value of left hand limit. Left hand means this one x less than 1. That is a negative side. Right hand means that is a positive side. This one is the right hand and this one is the left hand. So what is my f of x value here? Minus of x minus 1, x less than 1. So I mentioned here 1 minus. So minus of x minus 1, f of 1 minus x. See in the upper column, f of x equal to minus of x minus 1 because I am discussing about left hand derivative. So f of x equal to minus of x minus 1, x equal to minus of x minus 1. Instead of x, what is the value here? 1 minus h. What is the value here? 1 minus h equal to minus of, in the x place I can replace by 1 minus h minus 1. So plus 1 minus 1 get cancelled. What is the answer I am getting? Minus into minus plus h. See here, what is the answer I am getting? Plus h. Next I am taking as f of 1. Taking f of 1, it gives minus of x. Instead of x place I can replace by 1. 1 minus 1 equal to 0. Once again I repeat, f of 1 minus h. I am discussing the value of left hand derivative. So I have taken minus of x minus 1 minus of x minus 1. My f of x is minus of x minus 1. What is the x place here? 1 minus h. So I replace x by 1 minus h. X by 1 minus h minus 1. So plus 1 minus 1 get cancelled. What is the answer I am getting here? Minus of minus h. So minus into minus become plus. I am getting the value h. Come to the next one. What is f of 1? F of 1 equal to the same x value you can replace by 1. So, minus of 1 minus 1, the value equal to 0. So, limit h tends to 0. What is the value here? H by minus h. H get cancelled. What is the answer you are getting? Minus 1. What is the answer for left hand derivative? I am getting the value of minus 1. Now we are moving on to right hand derivative. Yeah, now we are going to see about the right hand derivative. We have already seen the left hand derivative. Left hand derivative, what value you got it? You got the value of minus 1. Now we are going to see about the right hand derivative. The same thing, limit x tends to 1 plus. That is right hand side 1. That is left hand side 1 minus. Here you can write as right hand side 1 plus. If it is a left hand side means 1 minus f of x minus f of 1 by x minus 1. F of x minus f of 1 by x minus 1. So it gives, see here, I can change it into x into h. Limit h tends to 0. Limit h tends to 0. What we have written in the left hand limit, f of 1 minus h. Here you can write f of 1 plus h. There f of 1 minus h. Here f of 1 plus h. 1 plus h minus f of 1 by 1 plus h minus 1 plus 1 minus 1 get cancelled. See here, limit h tends to 0. Limit h tends to 0. F of 1 plus h minus f of 1 by h. See it in the rough work column, the same thing. What is my f of x here? Because this is right hand derivative. Left hand derivative means we can take it x less than 1. Negative side. Right hand derivative means we can take it as x greater than 1. What is the value we can take? X minus 1. Right hand derivative x minus 1. So f of x equal to x minus 1. So f of 1 plus h. Instead of x value, what is there? 1 plus h. 1 plus h equal to 1 plus h minus 1. You cancel plus 1 and minus 1. What is the answer you are getting? H. See here, f of 1. The same way, f of 1. F of 1 equal to 1 minus 1. The value is equal to 0. So you can substitute here. Limit h tends to 0. F of 1 plus h equal to h minus 0 by h. So the value equal to h by h equal to 1. What is the answer for left hand derivative? Minus 1. What is the answer for right hand derivative? Plus 1. See what is the value we are getting for left hand derivative. Left hand derivative equal to minus 1. Right hand derivative you are getting the value 1. So it is not equal. Left hand derivative not equal to right hand derivative. So the function is not differentiable. The function is not differentiable at x equal to 1. The function is not differentiable at x equal to 1. I hope you understand this sum. See the 10th sum. Prove that the greatest integer function defined by, this is the symbol for greatest integer. This is the symbol for greatest integer. It lies in the interval 0 to 3. What is that 0 to 3? It is a open interval. See, equal to sign is not there. So, if it is equal to sign is there, it is a closed interval. Closed interval means we can take the value 0 and 3. If it is a open interval, we exclude that value of 0 and 3. So, greatest integer f of x equal to 0 to 3, the interval lies on 0 to 3 is not differentiable. First, we have to see it as x equal to 1 and x equal to 2. First, we will move on to sum. I will discuss about the greatest integer. What is greatest integer? See, this is the symbol for greatest integer. F of x equal to this bracket mentioned as greatest integer. Suppose, see here, draw a graph. This is not a sum, just I am explaining the sum, that's all. 0, 1, 2, 3, minus 1, minus 2. See, 3, 2. Listen here, 3, 2. It's approach like this. 3, 2. Approach. 2, 2. 1. It approach. See, 1. 3. Between 2 to 3, it approach in 2. It approach in 2. Between 2 to 3, it approach in 2. Between this one, it approach in 1. 1, 2, it approach in 0. It approach in 0. The same way, 0, 2, it approach in minus 1. It approach in minus 1. Minus 1 to 2 here. You are getting confusion, I think so. See here, see the value f of 0.1. Suppose f of 0.1 in the value of x, f of 0.1. What is the greatest integer? What is the answer you are going to write? You write the answer 0. That is 3 to 2. What is the answer you are going to write? 2. 2 to 1. In between any values, you will write 1. 1 to 0, in between you will write any values, you are writing the value of 0. See here, f of 0.1, you write the answer 0. That is the greatest integer. Okay. See here, suppose f of 0.9999. The answer is 0. 0.999, the answer is 0. Suppose f of 1.000, what is the answer? What is the answer? 1. Before the decimal point you can take, that's all. 1. F of 1.9999, what is the answer? 1. Before the decimal, you see this decimal point, before the decimal alone you will see, that's all, it's enough. Okay. Suppose f of 2.000, what is the answer you write? 2. F of 2.999, what is the answer you write? 2. Have you clear? This is nothing but a greatest integer. This is the symbol for greatest integer. See, differentiation is possible only for continuous and limit exist. Suppose they are given as x equal to 1 and x equal to 2. Just I am discussing, see here, I am not doing the sum, just I am explaining the sum. See, limit x tends to, this is a left hand derivative. I am taking the left hand derivative f of x. Left hand derivative f of x, it gives limit x tends to left hand derivative f of x, instead of x, what is the value here? X. See, minus 1, what is the value here? That is 1. 1 is approaching to the negative value 0. Because negative, it moves to the negative side. So, where it is approach? 1 to, it approaches to 0. See, limit x tends to 1 plus right hand side limit f of x equal to limit x tends to 1 plus x. What is the value you are getting? 1, because negative 1 minus means it moves on to the 0 point. 1 plus means it moves from 2 to 1 point. Okay, that is, you can take it as negative means this point and positive means this point. Okay, see here. So, limit x tends to 1 minus that integer, it moves on. What is the value you are getting? 0. 1 plus f of x, what is the value you are getting? 1. So, left hand derivative not equal to right hand derivative. So, the value is equal to, it is not differentiable. The same way you can see x equal to 2 also. See, x equal to 2, just I am writing here. You tell me, limit x equal to 2 minus, x equal to 2 minus f of x. It is nothing but what? Limit x equal to 2 minus, in the place of f of x, what is the value here? X. What is the answer you are getting? See here, 1 minus, you reduce 1, so you are getting the value 0. 1 plus, you reduce 1, you are getting the value 1. If it is 2 minus, what is the value you are getting? 1. You reduce 1. So, same way, limit x tends to 2 plus, x tends to 2 plus. See here, limit x tends to 2 plus x, what is the value you are getting? 2. So, it is not equal. Once again I repeat, see here, once again I repeat this also. See here, f of 0.1, you can think about this value alone before the decimal point. See here, it is a integer means 2 to 3, it approaches to 2. 2 to 1, it approaches to 1. 1 to 0, it approaches to 0. The same way 0 to minus 1, it approaches to minus 1. Minus 1 to minus 2, the value is minus 2. See here, the same way here. I gave some of the examples here. See, just I am giving an example, that's all. I am not doing the sum. X equal to 1. Just I am taking x equal to 1 minus. What is the value I am getting? 1 minus, reduce 0. 1 plus means as it is the same value. 1 minus 1 plus. Limit x tends to 1 plus, I am getting the value 1. So, it is not equal. So, it is not different.